Hello everyone, welcome to this video where I'm going through this paper from the October-November series for ASLevelMaths. So let's start. The first question is saying the coefficient of x to the power 3 in the expansion 3 plus 2ax to the power 5 is 6 times. It is 6 times the coefficient of x squared in the expansion 2 plus ax to the power 6, and we're being asked to find the value of the constant a, right? So we're going to start with finding the coefficient of x to the power 3 in this expression, right? And how do we do that? We say 5, choose 3, right? Then we open bracket 2ax to the power 3, then 3 to the power 5 minus 3, which is 2. So 5 choose 3, 5 choose 3 times this 2 to the power 3, 2 to the power 3, that will give us 80. 80 times 3 to the power 2, which is 9, you get 720 a to the power 3 x to the power 3. So 720 a to the power 3 is the coefficient of x to the power 3 in this expression, right? And we're being told that the coefficient of x squared for this expression right here is 1/6 times this one, right? Because the question said this coefficient is 6 times this one. So we're going to go ahead and write the coefficient of x squared for the second expression, which we're going to say 6, choose 2, ax to the power 2, 2 to the power 4, because that's 6 minus 2. Then 6, choose 2 times 2 to the power 4. We're going to get 240 a squared x squared, meaning this is the coefficient of x squared in the second expression, right? Now, having these two pieces of information, we go back to the question. We know that this coefficient is 6 times this coefficient, right? So 6 times the coefficient of x squared, which is 240 a squared, is equals to the coefficient of x to the power 3, which is 720 a to the power 3, right? Then 6 times 240, that's 1440 a squared is equal to 720 a to the power 3. So we can divide both sides by a squared, then this should give us 1440 is equals to 720 a. And for us to get a, we divide both sides by 720, and this should give us 2, meaning our a is equals to 2, right? So a is 2. Moving on to number 2. Find the exact solution of the equation that we want the exact solution, right? If you look at the right hand side, we can simplify it using our calculators, and if we punch that in, it will give us -30, right? So in other words, we're saying 1/6 pi plus tan inverse 4x is equals to -30, right? So we'll take 1/6 pi to the other side. We have tan inverse of 4x is equals to minus 30 minus 1 over 6 pi, like that. So taking this term to the other side, you are going to be left with 4x is equals to tan minus 30 minus 1 over 6 pi, like that, right? Then for us to get x, we're just going to divide by 4 both sides, right? So our x will be equal to 1 over 4 tan minus 30 minus 1 over 6 pi, right? That's our answer in exact form. No need to simplify it any further. This is it. Now moving on to the third question, number 3, which says the equation of a curve is such that the derivative dy dx is half x plus 72 over x to the power 4. The curve passes through the point P, which is 2, 8. Find the equation of the normal to the curve at P. Find the equation of the normal to the curve at P. So firstly, we're going to start by finding the gradient at point P by substituting this 2, which is our x value, into this dy dx expression. So substituting 2, it will be half, sub in 2 for x, plus 72 over 2 to the power 4, right? And if we punch this in our calculator, we will see that it goes down to 11 over 2. So this is the gradient of the curve at point P according to this derivative. And we know for us to get the gradient of the normal, it should be such that m1 times m2 gives us minus 1, because the normal is perpendicular to the curve at point P. So that value of the gradient of the normal would be minus 2 over 11. So that if we were to multiply these two, we get minus 1, right? So using this as the gradient of the normal at point P and the point P itself, we can get the equation. So we use y minus y1 is equals to mx minus x1, right? Then y minus this should be 8. Y minus 8 is equals to m, which is minus 2 over 11, x minus 2. Then simplifying this, we get y is equals to minus 2 over 11 x plus 4 over 11 plus 8. And if you simplify this, you get the equation of the line. Alright, I hope you got that. Just going to rub this out to make space for the following question. Then the part B is saying find the equation of the curve. Find the equation of the curve. So for us to get the equation of the curve, given this dy dx expression, we know straight away is integration, right? So we're going to integrate that. So we have dy dx is equals to half x plus 72 over x to the power 4, right? Which we can write as dy dx is equals to half x plus 72 x to the power minus 4. Then integrating this, we'll get y is equals to half x, we add 1 to the power and divide by the new power, plus 72 x, we add 1 to the power, giving us minus 3, then we divide by the new power, plus c. That's us integrating there, and this comes down to y is equals to 1 over 4 x squared, right, minus 24 over x to the power 3 plus c. Then from here now, we're just going to substitute the x and y value from our point P, because we know the curve passes through P, which is 2, 8. So we know at P, y is 8 and x is 2. So we're just going to sub those in, 24 over 2 to the power 3 for us to get c. Right? And this will be a quarter times 4 minus 24 over 8. That will be minus 2. So it's 8 is equals to minus 2 plus c. So our c is 10. So having that c value, we're just going to write the equation now with this value for c. So our equation will be y is equals to 1 over 4 x squared, 1 over 4 x squared minus 24 over x to the power 3 plus 10. And this will be the equation of the curve. And so moving on to number 4, it says the diagram shows the shape of a coin. 3 arcs AB, BC, and CA are parts of circles with centers C, A, and B respectively. ABC is an equilateral triangle with sides of length 2 centimeters. Find the perimeter of the coin. So there's need to show the triangle ABC, which they said is an equilateral triangle. There's this one. Okay, let me draw it a bit neater. Okay, so these sides are 2 centimeters each. Right? That's the equilateral triangle they're talking about. Right? And they're saying A, B, B, C, and C are parts of circles with center C, A, and B respectively. Right? Then for the perimeter, we know that the perimeter is the distance right around a shape. So in this case, it's CA, AB, and BC. That's our perimeter. So we're going to calculate the length of each one of these arcs, CA, AB, and BC. And we know for arc length it's r theta. Right? And if this is an equilateral triangle, it means each angle will be 60 degrees. But in radians, that will be a third pi. So each one of these angles is a third pi. Right? It's a third pi. And the values for r that we're going to be using will be these 2 centimeters. So the perimeter of the coin, we're going to say r theta for this arc, r theta for this one, and r theta for that, which is pretty much the same. So we can say 3r theta, right? So that will be 3 times r, which is 2, times the theta, which is a third pi, like that. And this will give us 6 times that, which is 2 pi centimeters. And that will be our perimeter there, right? Then we move on to the B part, which says find the area of the face ABC of the coin, giving your answer in terms of pi and root.